Good morning. All right. A little low energy because people have traveled so far, woke up too early, right? So we'll try not to, help you go back to sleep. We understand that there are lots of sessions that are happening right now, and we also understand that some of you have traveled so far to attend this talk. So first up, thank you for attending this session. We'll try our best to help you figure out what's happening right now in Yarn and where Yarn is going in the near future, right? Let's see if this guy works. Yes. So a very quick slide on who we are. I'm Vinod. I've been working on Hadoop for more than 10 years now. Committer, PMC, and recently Apache Hadoop VP. Hadoop is literally the only thing that I know, so please don't ask questions that are not related to Hadoop. And I have with me Sunil Govindan, who is a Hadoop PMC and one of the rising stars in the Hadoop community.
Yeah, thank you. Hi.
So quick agenda, it's pretty simple. We'll quickly introduce on the current state of the project and what we've done in the past year or so. So this is more of an annual sermon kind of thing where we go through all the things that happened in last year and then kind of guide through what's happening in the near future, right? So a very quick primer, as some of you might already know, Yarn is part of the Hadoop project. So releases and the timelines, everything that's covered with Yarn is tied to the larger Hadoop community. So it's very difficult to decouple each of these. So here we're painting a very simple picture of what happened in the last 1 year or so in terms of major releases. Apache Hadoop has moved from 2x to 3x, right? Since last year, we had a couple of minor releases in 2.8 and 2.9. And 3.0, it's been a major release that's been in works for a long time. And finally, late last year in December, we did a 3.0 GA release. And 3.1 was the next minor release that we followed up in April. So we'll talk through some of the things that happened along this timeline, but this gives a picture of how Hadoop itself evolves. In the course of a year, we typically have that many minor releases, and major releases do come every 1, 3, 4 years. And like I mentioned, Yarn is part of Hadoop, so I cannot actually talk about the Yarn community without talking about the Hadoop community. So we try to come up with a few statistics on what we had done in the recent past. So the pivot, most of what I'm going to show here is going to be on 3.1.0 release, which happened in April. And from what I know, because it's a recent release, almost all the cluster deployments that exist in the world today are based off 2x. And we took a specific version 2.8.3 to show you how things have changed, right? In terms of the total number of commits that have happened since 2.8.3 last year to 3.0, we had about, so there are two different metrics here. Since 3.0, which happened December, 3 months, and since 2.8.3, which was early last year, right? So we had a total of 3,700 commits across the board in Hadoop, HDFS, Yarn, MapReduce, and so on. And in terms of contributions, this is one graph that has never changed in all of Hadoop's lifecycle. It's kind of a power law. There are few people who contribute a lot of patches, but then there's a very long tail, right? All the names of the contributors are not here, but I would like to extend a quick thank you to all the community members. This project would not be where it is without all of your involvement, right? And yeah, overall, since 2.8.3, if you just look at the amount of code that got written, it got contributed by 456 contributors, and of which 46 of them have more than 25 patches. And then you'll see a whole lot of people who contributed with 1, 2, 3 patches, right? And our community values all of your contributions, so thank you. In terms of source code itself, how things have changed from 2.8 to 2x to 3x. Clearly, we added a whole bunch of new code, close to 1 million lines of code added, and 150K lines of code deleted. And that speaks to in terms of how much new stuff is happening in the community, right? And we also delete stuff that doesn't make sense anymore. So that's mostly on the community side. And yeah, to summarize, I would say it's been a vibrant community. Hadoop continues to evolve. As you guys know, it's more than a 10 years old project, right? And we are now entering a stage where Hadoop is kind of being the traditional project, right? So that transition in general is painful, and I'm glad to say the Hadoop community has been going through that transition pretty reasonably well. Right? So the rest of the talk, we're going to talk about things that have been happening and that are coming, but to help put some, some shape into how these things all relate together, we put some themes. So there are two broad themes, the platform theme and the workload theme. On the platform side, we're going to focus on scale, scheduling, usability. And on the workload side, we're going to talk about containers, new resources, and services, right? So that's how most of the rest of the presentation is going to be organized around. Sunil is going to now walk us through some of the key platform themes.
And thanks, Vinod. So let's look at scale in more detail. So there are tons of companies which are using larger clusters like Auth, Twitter, LinkedIn, Microsoft, Alibaba. And before the last year's summit, the biggest cluster was around in the terms of 8K nodes. And currently, we are at around 40K nodes in a federated cluster, and we are at 20K nodes in a single largest cluster. So where are we going to do with this, the scalability? We want to go till infinity. That is something like to put a number like 100K or 400K number of nodes. To help this to go beyond to this the 100K or 400K nodes, we have this YARN Federation. Thanks to the community, to Microsoft folks helping in this level. So the federation, how it works is basically it divides the whole number of nodes into small subclusters, and the federated RM, which is actually negotiate with these subclusters so that the respective application will get its demanded resource. So basically, the application can run on any node. So this is an architecture diagram of how the federated RM will look like. So to give you more color, we have a related session, which is given by Carlo and Subru from Microsoft, which will give you the new advanced improvements they have done in the YARN Federation in more detail. Also, we have another session from Alibaba, which is actually how they are doing the Hadoop YARN 3.6, and which will be done by Wei and Ren. It will be happening Thursday. So now let's look at the scheduling theme. So in 3.x, there are a lot many features coming in scheduling, which will actually in align with the same scalability part. So to scale your clusters to the highest level, you need to do a much faster scheduling and more effective scheduling. So let's look at more detail. To start off with, we were actually introduced global and fast scheduling, which is done in YARN 5.139. So what are the problems as of now in YARN is basically we look at one node at a time. So when we do one node look at a time, we'll be able to do the allocation in a very defined speed. So that actually was causing out the performance of the scheduler was not at that high level. Second, there was a lot of course grain locking were there. So as part of this initiative in the community led by Vanta, we have actually now could able to look multiple nodes at the same time. So and we also fix a lot of grain logs, and we have multiple threads which can do the allocation at the same point of time, with which we can do much faster allocation. That is in terms of 3,000 containers per second. So this is pretty fast. So that means we almost improved around 10x performance in terms of the container allocations. But more to is that we can do faster allocation, but we can also do effective allocation as well. So when I talk about YARN in terms of the multi-cutter way, where we are scheduling these long-running services, if you look at one node at a time, maybe there may be some other nodes in which this particular long-running service may be better suited with. So if you're looking multiple nodes at the same time, we may be able to find a much better candidate that will be more better than the first one which may be there. So that also give the better placement strategy will help us to get much better container allocation. Looking more in detail how we have done it. So we have the scheduler states, which on the left side, and we have the multiple threads where the allocation can happen. So in each of the thread, we will be submitting multiple allocation proposals. These proposals will be based on the application demand saying that I need 5 containers or 8 containers of so and so memory and CPU or GPU. So all the demands will be created as a proposal and submitted to each of these allocated thread. At the same time, this will be checked on which queue it can run, whether the resources are there or not. All the checks will be done in each of the thread. Finally, it will be committed to the scheduler. So thus, we will be able to do a much faster scheduling and more effective also. So beyond this, as I mentioned earlier, so we need to do much optimal decisions also. as we move ahead, like we also need to know that, okay, can I place my container with specific affinity or anti-affinity kind of a model? For example, if you look at the scenarios where you want to run an H-based app, but you want to run also Storm on the same machine, because you'll get much better I/O reads if you run your Storm along with your H-based region server. But you cannot run two region servers on the same node, because then it will be more I/O sensitive. So if you have an anti-affinity placement set, then you may not be running two region server on the same node. So these are some of the better placement strategies we can actually put to YARN, and the application can place their containers in a better nodes, and it will give you much better performance as well. So along with this, so we have a detailed talk about this, like from Wangda and Costas from Microsoft and DataWorks. This will be giving a much more detail about how this particular placement constraints have been done, and how it helps to run long-running service in YARN. So do attend this talk to get more details about this. So let's jump into a few more improvements what we have done in YARN. So one was in capacity scheduler, we were able to configure only percentage model kind of allocation. So you say that, okay, 100% is the root level, then the queues will take 50%, 30%, or 20% like that. But when you take this to a cloud model, it will be very difficult to configure the percentage, because you got a number of nodes, and these are some of the resources I have. So if you want to do the queuing model, it will be very difficult to go with the percentage. So there, if I say that, okay, I'll give me extra resources on this particular queue, it will be much easier to configure and manage the cluster. So that is what we have done with this particular Jira, YARN 5881, and where the configuration could be as simple as this. The memory is 24 gig, or vCost 20, or GPU 10. Then you split it to the sub queues, and you can say which queue needs how much, because some queues may need only for GPU, you can give the whole 20 GPU there. So by this, you will be able to do a better configuration for the new resource types added. Going to another feature, what we added is like the auto creation of leaf queues. So earlier, we do have the user mapping. So it means, okay, user comes and submits the application, it will go to the respective queues, which is mapped to that user. But this also required a lot of configuration to create a custom queue and etc. But with this feature, the user can come and submit the queue, submit the application to the YARN, and YARN will auto-create the leaf queue at the point of time based on a template which is already there. So that much of resource it will take automatically, and the application could run seamlessly without any kind of extra configuration. And once the application has finished its runtime, the queue will be automatically deleted. So this flexibility will add more power for users, so that they can easily, a number of users can actually use YARN without much hassle with the queue management. So with this, I'll go to the usability theme of the whole YARN platform. To start with, so we have done API-based queue management, because you all know that the queue management is one of the toughest part. If you have around 20 queues in multiple hierarchies, to manage the queues and you have to add a new queue for the new department which is coming in, or change, new nodes are getting added, then you have to do some tuning in terms of percentage. It's pretty difficult. So you have to literally change the XMLs and fire some CLI commands. With this API-based improvement, where the user can simply use some REST APIs with a defined spec model, and it can actually add, delete, or manage the queues at runtime. Also, we have done some improvements in logs, by which you can get the running container log by using a simple CLI command. So it's more easy to get what is happening in your, to your application at runtime itself. No need to go to the UI or just CLI. You give the container ID, you can see the live container logs. With that, I'm just taking you to the new UI, which is actually part of 3.0 onwards. And this new YARN UI, which is much evolved from the older YARN, this is more better in terms of admin to know that what is happening in my cluster, and also what is happening to my applications as well. And it gives you a much better perspective about your applications, your cluster, your nodes, your resources, etc. And this is about a second view about how the application page looks like. So you can do a much better filtering, so that you'll be knowing, our admin can easily know that, okay, how the whole applications are running, and what category, which user has this many number of applications, etc. So with few clicks, you'll be able to get a lot of answers which were not there earlier. So with this, I will go to ADS, that is Application Timeline Server v2, which is a revamped version from the 1 and 1.5. So this ADS v2 is basically back from HBase. So why we needed that? Because with respect to Hadoop, the storage of number of applications it is running and number of containers it is running, that itself becomes a big data problem. because we have to, that much of number of, if you run this cluster for a long time, the number of application and contents are so huge, so we have to find some metrics, or why my application is running slow today. So these kind of answers are not very easy to solve at the present of time. So with ATS v2, we will get all these kind of answers with few REST API queries, etc. So we'll be able to know what is happening in my cluster. But it also improved performance because we are using HBase as a backend, so better scale. The cluster could be scaled massively big if the data is too big. A small architecture diagram also here, just to show that okay, how distributedly we are writing and reading from HBase for ATS v2. So with this, that's another talk, which is actually how you can migrate your load from Hadoop 2 to Hadoop 3. So it's a very detailed talk. So all the migration strategies, so what are the do's and don'ts, and how easily you can migrate, what kind of migration modes you can use. So all the details will be given in this talk. So I suggest you to attend this talk to get more idea. Yeah. So with this, we are going to workload themes. So I'll hand over Vinod.
Yeah, but we could also take a small stop here before we move into workload themes. Does the platform theme make sense? The key takeaways are YARN is built for scale, and we are future-proofing for even larger scales with federation. Scheduling, YARN has always had a first-class notion of data locality, and we are now extending that to more powerful primitives like affinity and anti-affinity, right? And a bunch of efforts related to usability. So any questions that folks have that that you want to get clarified, we can spend a couple of minutes here. Yes, please. Yeah, so the question is, the queue management in YARN had historically been very static, right? You say marketing gets 50%, finance gets 20%, engineering gets 30%. That's not how it works. Engineering gets a lot more capacity. But then, maybe engineering goes on a weekend and somebody is working behind the scene, and during the night, maybe the other side of the world is needing more resources, right? So historically, that's been very static. And so the question is there a way of doing some sort of time-based capacities, right? So I think you kind of answered some of the questions. So the API-based management solution kind of helps you with that, because historically the config files were very hard to wrangle with, right? But that's one part of the story. The second part of the story is, in some cases we've seen that people basically say, why even have queues, right? Why don't you ask people to say, tell me when you want to submit this workload and how long it's going to run for? And then why don't we build a system which actually magically figures out and puts people, right? Just like you go to a calendar and say, book this conference room, right? And there is no central planning. It just happens in a distributed manner, right? So our friends at Microsoft have been working on a feature. It's been a pretty research-heavy project. And the focus there is exactly that. You do it through reservations and through deadline scheduling, which also puts some of the responsibility on the user. The user should actually say, my job is going to come here, my pipeline is going to start at this time, at midnight, and it has to finish by 4 o'clock. And now you figure out how to share resources, et cetera, right? So I would definitely point you to that direction. There's some work there that's pretty relevant. There was one more hand that was right here. Yeah.
Is the embedded timeline server, is the HBase in the timeline server embedded?
So the question is the HBase in the timeline servers embedded? So there are multiple modes here. There are use cases in cases, for example, Twitter, what they do is they have multiple Hadoop clusters, and they want to get all the metrics from all those clusters into one central place. So they can answer a question like, what did this user do across all these clusters, right? So you can actually configure a central HBase and point all the YARN clusters to that. But there are other use cases where they just want to have one HBase per cluster. There also you have multiple options. You can bring up your own HBase and point YARN to that. Or there is a new feature called system services in YARN. We're going to talk about it, wherein you can actually say, hey, this HBase is not my user's HBase. I don't want anybody to mess with it. Similarly, I don't want YARN to mess with the regular HBase. So why don't you bring up a specific YARN on top of specific HBase on top of YARN and use it for your metrics? So we have all those options. There's also one more option, embedded HBase for very small clusters. I hope that answers your question. So yeah, why don't you keep the rest of the questions for later? We'll go through the workload themes now. So let's start with containers. I'm sure everybody is interested about containers, right? So a couple of things. Containers is a very complex space. I'm going to tell you how we are thinking about it. This is the first thing that happened was Docker years ago, 3-4 years ago. Docker came into the fore, and Yarn has always had a notion of native process containers, but that's simply a glorified way of saying a process tree, right? You start a MapReduce job, Spark application, and it's a process tree, and Yarn manages it, makes sure it doesn't go beyond the resource limits, right? Docker came along, and to me, one of the most powerful things with Docker is the packaging, right? You create an image on your laptop, you can actually take it to any cluster, anywhere, and run it without any additional steps, right? It's self-contained, and that was one of the things that made Docker very powerful to me personally, right? And Docker was also building on top of C groups and the Linux resource model. So putting both of them together, we realized, what if we make bringing an existing Docker image to a Hadoop cluster easy, right? And that was Yarn 3611, where, again, this has been a long project as Docker itself evolved over time, and it got stabilized over time. We started pulling in more and more features from Docker. And the way you would do it is, it's kind of a last mile decision. You don't actually say, hey, there is a Docker app that is built separately, and there's a non-Docker app that is built separately. You build your app, and you finally decide whether you're going to give Yarn a tarball, or you're going to give a Docker image, right? Everything else stays the same. You want to use Yarn scheduling features, you want to use timeline service, you want to use the UI, you want to set quotas, preemption, all of that stays the same. The only thing that's changing is whether I built a Docker image or whether I gave a tarball, right? And what that allows you to do is, on the same physical Hadoop cluster, you can run your MapReduce, Thales, Spark workloads. You can also run Spark on Docker. You can run LLAP. You can run, you can have a mix of all of these based on how, the apps were built in the first place. And one of the most common themes that I see is people have these notebooks, and notebooks because it's a recent phenomenon, they're all built on top of Docker. So using this, you can say, hey, Spark is running outside of Docker, but let me bring up a notebook which has all the Python libraries that I want, which the admins don't care, which the other user also doesn't care, right? Bring it up and interact with Spark and do something and go away, right? So that's one use case we changed. And like I was saying, it's a last mile decision, which means you can run Spark without Docker, you can run Spark with Docker. And the reason why you would want to run Spark with Docker is, think of things like PySpark and SparkR, right? Each of those applications need a whole bunch of libraries, and typically today what happens is the user goes to admin, and admin asks admin to say, install these libraries. And if you happen to be the first user, you're fine. You go install, and admin does it easily, right? If you happen to be the 10th user, the admin will have to now go through the dependency hell, or the outcome may even be that admin says, go away, I cannot do this for you, right? By putting your PySpark and SparkR in a Docker image, you're basically telling the admin, this is what I worked, this is what I've tested on my laptop. Just run this Docker image for me. And the way the architecture is, we don't change anything in Spark, right? When you submit the Spark application, you pass through 3 environment variables. One is the image name, right? Second is registry, location, etc., right? Everything stays the same. The executors get brought up inside the Docker container, and voila, you can use your libraries. So that's one angle. There's a different angle to containerization, which is, hey, big data is this whole island, and containers have been coming up across. What if I containerize the entire big data platform? Right? That's another question that we get a lot. And that one is also a little complex. So historically, Yarn, we have always focused on jobs, big data, data processing, and so on. And if you have seen containers, Yarn will also look like, hey, if I have a generic container that's got nothing to do with data, can I run this in the Hadoop cluster, right? So that's been our evolution. And things like Kubernetes, Mesos, Docker Swarm, they started on the other end, which is, hey, run this web farm, on top of Kubernetes. And slowly they're realizing that, hey, there are some apps that I can actually run in that containerized world, but it happens to be a big data app, so how do I do it? The data is there, I put my application on Kubernetes, how do I make them interact? How do I secure this, et cetera, right? So definitely there's been a merging of sorts, and there are areas where both sides are playing. And one of the things that we have done ourselves once containers came in is we ran Yarn on Yarn. I'm going to tell you why we did that in the next slide. But overall, the landscape, if you really simplify it to the nuts and bolts, should I run Yarn on Kubernetes and all the Yarn workloads on Kubernetes? Should I run Kubernetes on Yarn and run all the Kubernetes workloads closer to the data? Or do I run both of them side by side and somehow share resources? Because ultimately, we all want to use our clusters to the best possible utilization, right? So it's a very deep topic. So there is a special talk focused around this exact one. It's called Big Data and Containers. If you're interested in this area, please go there. Our goal is not to say, do this, right? Our goal is to help you understand the complexity. And we'll give you a bunch of recommendations and touch on different properties. And you can make the decision for yourselves. Now, going back to the YARN on, why did we do that? So as I'm also from Hortonworks, so we are in the business of testing Hadoop before it hits your production clusters, right? And that means testing it on different OSs with different databases. There is a whole lot of combinations. Somebody has wire encryption, somebody doesn't have wire encryption. And the way we do that inside Hortonworks is we bring up little tiny clusters every day, every night, each focusing on a specific configuration matrix, and then do a bunch of tests and bring it down, right? And in the past, it was running in a VM-based environment, and we were not getting the kind of utilization that we wanted to get, right? And we said, hey, and the second problem was how people share resources in that cluster. So think of it like a massive Hadoop cluster, just like in your production environments. And the YARN team basically says, I want to test my YARN changes. And the Hive team says, no, I don't care about your YARN changes. I want to test my Hive changes first, right? So there is a resource management problem there, and people are fighting, saying, give me VMs and give me VMs, right? So we looked back and said, hey, YARN has already built these scheduling features for a long time, and our customers are using them, our users are using them. Why not put that and containerization together and figure out if we can have a more flexible, better utilized environment, right? And that's how what we internally call as Y-Cloud came up. It's basically a container cloud based on YARN. It puts YARN, the latest stuff that I talked about, plus containers. And instead of the containers coming up inside VMs, we actually bring Hadoop clusters on top of Hadoop clusters, right? And that's how we've been testing our softwares for more than a couple of years now. And yeah, if you want to learn more about how we test all these combinations, there is a talk by Sunita from Hortonworks. So, and testing Hadoop itself is actually a pretty big deal. It happens behind the scenes, so I'm sure not a lot of people know about the intricate details that go on there. So if you are interested in this specific area, please do go to the talk. How are we doing with time? All right, we're shooting up. So I'll quickly zip through some of the resources stuff. Historically, YARN had support for only CPUs and memory. Over time, we realized that more and more resources are coming, because if we don't evolve along with hardware, we will be left behind, right? And the most prominent ones were GPUs and FPGAs. So instead of hacking YARN more to keep adding more resources one by one, we said, why don't we build a generic framework? And that's how the notion of a resource, a vectorized resource came in. And so using this feature, you can basically say, in this cluster, I have X resources. And on this machine, I have a small percentage of those. YARN, please treat them as abstract notions and then schedule, right? You can use it for GPUs, FPGAs, but you can also use it for things like licenses, where you say, hey, from this machine, I only want 2 containers to use this license. And only after they finish and relinquish the license, you give them to the next one, right? So now YARN has that generic notion of scheduling based on countable resources, right? The other thing that we've done is the way people size their containers is pretty ad hoc. Somebody says, I need 4 gigs, and the second guy says, I need 4.1 gigs, right? And YARN basically rounds all of them up, and there's sort of an internal and external fragmentation. So here also, we look back to cloud and said, hey, people understand cloud, and in the cloud, they don't actually say, give me 4.1 gigs. They say, give me small container, large container, extra large container, right? So we added a feature called resource profiles, wherein the admin in a specific cluster can say, these are the 5 types of container sizes that are available. Why don't you go and pick and choose, use one of these profiles, right? Of course, if you still want to have the fine-grained control, you can use it. But if you want to simplify it, that's how you can use it. On the GPUs front, people have asked, why are you adding GPU support YARN? I mean, the other systems doing it. What's specific about YARN that we want to do, right? And the answer is 2 things. One, the data is sitting in your data lake. If you want to shuttle your data across clusters, that's going to be a problem. Number 2, GPU is an expensive resource. And today, we actually see it in the market. One data science team buys a bunch of GPUs, uses it for themselves. The other team does it for themselves, and we kind of go back and say, hey, this is how Hadoop was before. Everybody was building their own little clusters, and there's a lot of internal resource waste. By putting them all together and pooling resources together, we can actually get better, bang for the buck, right? So those are the 2 reasons why you want to put GPUs in a YARN cluster. And once you put them, once you pool them in a central place, how do you actually isolate GPUs? And that's one area where it's an ongoing journey. Right now, we support per GPU device, thank you, per GPU device isolation, right? Let's see. There is an interesting talk which runs distributed TensorFlow inside containers plus GPUs on a YARN cluster. That's a lot of buzzwords. But if you want to unpack those buzzwords, you can go to this talk. You'll understand what's happening there. And deep learning. That's the biggest buzzword of them all. Yeah, and some of our friends at Intel, they also have FPGAs to sell and the FPGAs to use. So building on top of the resource vector in YARN, they've enabled FPGA resource in YARN. So the last one is services. We talked about YARN supporting jobs for a long time. So this is another long-time coming effort. For those of you who know, there is a project called Apache Slider, which is an Apache incubator. It has recently retired. We've taken all the lessons from there and most important code pieces from there, and we merged into YARN. So in Hadoop 3.1, you can actually run jobs on YARN. You can run containerized workloads on YARN, and you can also run services on YARN. And between containers and services, you can mix and match. You can run services without Docker, with Docker. You can run containers, even though whether it's a job or a service. Like Spark on Docker is the example where you can run a job with containers, right? And we did a whole bunch of work here. And the way you actually build these applications is a simple, you don't write code anymore, you write a simple JSON spec. I don't know if you can see it from here. But if you don't want to deal with this also, you can actually go to the UI. You download Hadoop 3.1, there's a UI. You can basically say, run this service, this is the Docker image, run 5 copies of it. You click deploy, it'll just run on top of YARN. And one of the examples that we've used to demonstrate that this works in a production workload scenario is LLAP. LLAP is migrated to running on top of YARN services, and that's a classic example. Let's skip through that. We're short of time, and I'll pass it on to Sunil to talk about some of the futuristic stuff.
Thanks, Vinod. So let's look what is actually beyond 3.1, which is 3.2 plus. And to start off with, we have the node attribute feature, which is coming in YARN 3409. So normally, we have this concept of partitions in YARN, where you have a set of nodes of certain characteristics, and you divide to certain partition, and that partition is actually could be shared by the queues, so that those nodes with that specific kind of partition will be running on that particular nodes. But this is something pretty much in a finer level or a top level. But when we talk about attributes, there are more number of attributes for a node. For example, I just shown two sets of partitions here, partition 1 and partition 2, and we have around 18 nodes are there in the total cluster. But when I define the partition 1 with 15 nodes, and that is shared between QA and QB, and I have another partition with 50 nodes, which is shared with 4 queues. But if I'm just trying to focus on 4 nodes, node 1, node 16, 17, and 2. There are a lot of different, because some of the nodes are running in RSHL, some are on Windows, some are on SUSE, some has the GPU, some is running with JDK with version 8, some are with JDK with version 7. So when you have this much number of complex attributes on a node, you can't manage this with node partition. So that's where the node attributes comes into picture. So where you can say that, okay, I need my containers to run only on JDK 1.8 nodes. So that may be a subset of around 8 or 6 nodes. Maybe I also need to run with JDK 1.8 also in Windows. So I can say all these kind of complex strategies, and node attributes will really help in terms of achieving that. So we have the rich placement set, which I mentioned in one of the earlier slides. So with the help of node attributes feature, we will be able to achieve that particular power from YARN. Going next, the container overcommit feature. So as you know, so if I need to run a container, I'll say maybe at some point of time, the whole container runtime, it may be taking 16 GB. But the allocation will be happening for 16 GB. Maybe the other time, it may be using 8 GB or 6 GB, pretty much less. That means we are wasting a little bit of resources there. So this the overcommit feature will help us to run more containers on the same node by using that extra resource at the given point of time. But when it is needed, that point of time, these containers could be preempted. So we say it as guaranteed and opportunistic containers. So this feature is also coming in the next release. Quickly moving to auto-spawning of system services feature. So as mentioned, YARN can support these native services as of now. But for example, ATS itself is using HBase. So when you want to use that HBase only for this limited cluster, when YARN comes up, we can also start this ATS by itself. That is for the HBase part. So that's where system services will help us. So this is something like initd. of normal Linux, something like that. So YARN, when starts, admin can say these are the set of services we should auto start along with YARN. So that is one of the power, and by which you'll be able to use YARN as much of like a very common platform to run any number of services. When the YARN starts, admin need not have to worry about those things in terms of the lifetime. Moving to the next one, running deep learning workloads on YARN. So recently we are doing a work in YARN 8220, which is actually integrating TensorFlow on YARN, and how easily we can run a distributed TensorFlow or a normal simple single node TensorFlow, and with Kerberos, without Kerberosing. So all the complexities, these are actually done with the help of a native service feature. So we have done some couple of small scripts to help to run this workloads. The second option is that, where you can simply use a simple command like Python submit py and say that, okay, what is the configuration path where the configuration files are there for this particular TensorFlow job. You just say the input spec, the Docker image, artifact, say whether it should be done distributed or it should be done along with Kerberos. So just see all these things. It will auto-submit the job to your YARN cluster, and the TensorFlow loads will directly take up from there. So this as easy as this, we can run this TensorFlow on YARN. Also with another command called YARN app launch. This is part of normal native service. You can specify the JSON spec, which actually we have shown in the slide. So something like this.
I think
yeah,
that covers everything. So we have maybe a minute for questions. Let's see if we can steal some resources before they preempt us. So the question is, Hadoop 3.1 features are part of HTTP 3.0? Yeah, that's right. Yes, yes. Not the future stuff that's coming soon. Any other questions? Yes, please.
In older days, the preemption was only by kill. Have you entertained other preemption methods?
Good question. So the question is, in the older days, or even present day, unfortunately, preemption is always by killing containers. There are a couple of JIRAs where there's renewed activity on preempting without killing, and I can parse it a little. There are different types of resources. Like if somebody is trying to use GPUs, the only way we can evict them is by moving them out, by killing them, right? Similarly, memory is not a fungible resource. So the JIRA that I talked about, it enables preemption by reducing the C group, but it only works with CPUs. Yeah, it's not a finished feature yet, but there's been renewed interest recently. Yes, please.
So you can say in any way, like if you know these nodes have these versions running of certain software, you can say that is one of the attributes. So you can specify in two different ways. One is distributed way, wherein which admin can go and configure that, okay, this is a set of nodes with certain attributes. But also, if the node manager, we can have some auto discovery scripts which are available. So it will detect a certain number of softwares, but you can edit the script by which the node manager starts. It can automatically pick up the version and the type of software that you're looking for, and it will send to RM, then that will be the attribute for those nodes. So both sides we are supporting. Yeah.
Yeah. So the question is, the admin has to install Docker versions, and in fact, we also went through the same trouble. Which Docker version should we use? Which OS version we should use? Because Docker itself has been a journey, and because we started on this journey like 2-3 years ago, we've actually gone through the same pains. But we finally have specific OS versions that we can use. Maybe we can talk offline of what worked for us. Definitely CentOS 7.4, RHEL 7.4 is the latest version where things were reasonably stable. Okay. The second question is, I'm dealing with Docker versions and YARN versions, and Docker is changing, YARN is changing, and it kind of goes back to the same thing. What we realize is, if we can settle on a Docker version, interacting with YARN versions is not a problem, because the only things that we are changing in YARN is, oh, there's a new Docker version with a new feature, let's integrate with YARN. So if you don't need that feature, you can use the old version of YARN. Hope that answers. Yeah. I think he raised, he submitted job first. Yeah, time's up. We can take some of these questions offline. I'll take this last one, and then we can take this offline. So on Apache, we haven't published which Docker versions we have tested with, but maybe that's what we should do, and say Hadoop 3.1, YARN Docker support works with this version. Yeah, we'll probably do that. Thank you very much for attending the talk.
Yeah, thank you.